Okay, so as you go to, and I'm not going to answer any of the questions on your homework. I have provided the answer key for each section. So for homework in section 1.3, you'll have a lot of graphs, okay? A lot of curves, and you have to analyze them. By no means I covered all of them. So let me just give you some examples here. Let's say if your vector valued function r of t is cosine of t plus 1, sine of t, and sine of t over 2 or something. Okay, so how would you find that? Well, you can't just do cosine x squared plus y squared, because x squared plus y squared is not going to mean anything. Right? But notice here, you can subtract x 1 from x. If you subtract 1 from this x here, it'll be cosine t. And so you can square that, and then you can square y squared. You can square y, and so that would be cosine squared plus sine squared is equal to 1, right? All right. So that means what? What can you tell me about this? Yeah, try to figure this out. What kind of surface all the points will be on. Okay, so you notice this is a circle. And in fact, because this is three-dimensional, this is a vertical cylinder, a circular cylinder with radius 1. But the center is not 0, 0. That's center is 1, 0. Okay, it's a vertical cylinder, which is what I drew here. And so that's where all the points will be, regardless of what t is. Now, of course, you know, it's not the set of all points. The answer, the range is not the whole cylinder. It's a certain subset of cylinders, this cylinder. When t is equal to 0, you have 2, 0, 0. That's this point here, right? And let's try to see what happens as t increases from 0 to pi over 2. What happens? What pi over 2? Okay, at pi over 2. This will be 1, 1, and then this will be sine of pi over 4, which is going to be square root of 2 over 2. And then by the time you get to this point here, that's when you have t is equal to pi. And then, okay, so this is where t is equal to pi. When t is pi, you have 0, 0, and then sine of pi over 2 is 1. So it goes up to this point. Now, what's going to happen here? Here's what the graph is going to look like. See, the thing is, this one continue to increase up until this point. Oops, that's not a good picture here. Let me erase this. And so the idea is, as t goes from 0 to pi, this z will also increase like this, right? So this is where is that? When t is equal to pi, you have 0, 0, and then sine of pi over 2 is 1, okay? And then it kind of keeps going down this way, right? So it's going to be a curve, right? It is circular, but it kind of goes up here and then starts to go down this way, down back to this point, which is 2, 0, 0. Right, so how do you figure out these things? Well, you know, you have to think, you can plug in some numbers if you have to, and try to analyze this. Again, you will see lots of questions like this on your homework, which, as I said, I love these problems. It'll get you really start to think about 2 or 3 dimensional space, and that spatial thing, you have to just learn, you know, grasp that concept in 2 or 3 dimensional world. It's not that hard because all of us do live in 3 dimensional space, at least the last time I checked. Okay, so the next one, how about this? And then you'll have questions like this. So find the vector or parametric equations for the intersection of, let's say, x squared plus y squared is equal to 4. just giving you some examples, some simple examples, and z is equal to xy. Think about this, maybe you can sketch the graph of this too. Maybe you can do that too, sketch. All right, see if you can do that. And you can pause this recording and come back to it if you like. Okay, again, you know this is a vertical circular cylinder of radius 2. That's what I am just about to draw here. It'll look like this. Here's a point that goes through the negative x-axis here, and this is as far as you can go. So it'll be something like this, okay? And z is x times y. So if x is 0 or y is equal to 0, this z is 0. Otherwise, in the first quadrant, x and y are positive, so z is positive, right? So what kind of a graph is this? Well, it has to start at here when, well, it doesn't matter because you don't know where it's starting, okay? But it does have to go through these points here. And here it kind of goes up like this and down like that. And then it starts to go down, right? And it starts to keep going down until you get to this part here, and then starts to go up again, and then goes down again in the fourth quadrant. So it's up and down thing, all right? How do you describe this? Well, the intersection is one-dimensional. It's a curve, right? So since it's a curve, you should be able to write this in terms of a vector valued function. So what is that? X is equal to. Now the thing is, every point is on the cylinder, right? So anytime you want to describe points on the cylinder, you want to use that cosine sine combo. 2, because the radius is 2 cosine t, 2 sine t, that will guarantee that the first equation will be satisfied. The second equation is also simple if you think about it. What's z is equal to xy? Well, simply multiply x and y. And so I didn't write this in such a nice position here. Maybe, oh, what's happening here? Let's move it over here. Okay, so the answer to this question would be just write down z as a product of x and y. That's 4 sine t cosine t, okay? And that's it. And as t goes from 0 to 2 pi, it's going to go up and down, and you will be graphing this. And that's exactly what this curve looks like. Okay, quickly, one last example here. I want you to sketch t cosine t, t sine t, and t. This is not going to be the standard spiral as we saw before. Okay, see if you can do that. And then we will conclude this section. All right, so anytime I pose a question like that, I'm assuming that you can at least stop or pause the video, try to work on the problem, and then come back when you think you are close to or you have found the answer. Okay, so this is your x. Oh, what's going on here? Something is strange. Let's erase this. Okay, so the point here is, I'll use my pen. This is x, this is y, and this is z. Okay, and z keeps going up straight. I mean, z and t are equal, so as t increases, z just increases. Right, x squared plus y squared, this time it's not equal to 1, right? That's t squared cosine squared plus t squared sine squared. That's t squared times 1. And that's z squared. So if you think about this, I mean, you have been able to draw things like this in chapter 2, right? You see that chapter 2 is becoming pretty significant because today we've seen an ellipse. We've now seen, what is that? It's a cone. Right? So this is the cone, x squared plus y squared is equal to z squared. Actually, it's a double cone you get on the other side as well. And maybe I should have, okay, because I didn't specify t is not negative. But if t is negative, this is going that way. And so what's happening here is this. As t, so this means as t increases to infinity, okay, remember cosine squared plus sine squared is equal to 1, but it is the radius t circle. The radius in terms of x and y also increases to infinity. Okay, so the first thing it tells you is it's in all the points are on this double cone. When t is equal to 0, clearly it's right here. Okay, and then as t increases, remember cosine and sine will start the circular motion in terms of x and y. Z will continue to go up, and then at the same time the radius is going. So it's not a helix like this anymore because the radius changes from 0 to infinity. So this is what is going to happen. Okay, and if you continue to go this way here, when t is negative, you're down here because z is negative, and when t is positive, you're up here, right? So this will be an expanding spiral. I don't know if there is a specific name for it, but that's a kind of curve you are to identify. Okay, so I hope this has been helpful, and you should now be ready to do all your homework from section 1. Lots of exciting things are happening here, and now you are seeing things that you haven't seen before. All right, so that concludes section 3.1. I am back at this good grapher screenshot, and in the back you can see the multiple version of that helix. If you have another parameter, say t and s, you can create something like this, and that's what I was referring to as your infinite circular parking lot, the sort of structure you see right by the Chicago River, if you have seen those two towers of a parking lot. Anyway, so you will see a lot of things that you haven't seen before, and the things so beautiful that you kind of wish that your friends and family and relatives could share with you, although they may not have any understanding of what's happening, but you have the privilege of seeing these beautiful things because now you are seeing a glimpse of this world called mathematics. Okay, I will see you in section 3.2. All right, I'll talk to you later. Bye.